So hello everybody, today we will be designing an OR gate using data flow modeling. Data flow modeling, as we have already discussed, is one of the most easiest modeling in all the three modeling styles in Vhdl. In Vhdl there are three modeling styles, that is data flow modeling, behavioral modeling and structural modeling. So data flow modeling is the most easiest one, and we are going to implement OR gate, that is also one of the simplest and most basic gate of any digital circuit. So we can see the truth table right here. In the truth table you can see that there are two inputs A and B, and there is one output, that is Y. Okay, so here you can see that for the two inputs, if we give 0 and 0, 0 and 0 as input, we get 0 as output. If we get 0 and 1 as input, we get 1 as output. 1 and 0 as input, 1 as output, and 1 and 1 as input, 1 as output. So this is our OR gate, and you can see that for 0 0, when both the inputs are 0, we get 0 as output. This is the only case where we get 0 as output. This is the diagram. You can see that in this diagram there is one input here, one input here, and one output here. Okay, so this is a two input and one output gate. We will design it using Vhdl. So we have opened our Modelsim and we will click on Jumpstart here. And we will open a project. Since in the last video we have already created a project, we will open it right here. Okay, so we will click on OK and our project will be opened. We will double click here, or we will right click and add to project, new file. So we can add a new file here. So I will write OR gate and click on OK. So OR gate will be added to our project. We will double click it and this will be our code writing window. So we will write the code of OR gate here. So for any Vhdl code, the first statement is to import the library, that is import, or here we can write library IEEE, and next we have to use the library, that is use IEEE dot std, that is standard underscore logic underscore 1164 dot all. We are using this library. So once we have written this, we have to write the entity block. So here we have to write the entity. We'll name this entity as OR gate. You can give any name, but make sure the name should be self-explanatory, so you can understand later on that what gate you have implemented or what circuit you have implemented just from the name itself. So entity OR gate is, and next we have to write the ports. So in the ports we have already seen. So we have already seen that this is a one input. Then what is the two input and one output. Okay, so we have two inputs and one output. So we will simply build this, that A and B are input, that is A, we will write in std underscore logic, std underscore logic. Similarly B was also an input, B in std underscore logic, and Y was our output, so Y out std underscore logic. So once we have written this, we will click on enter and we will close our port and we will end our entity, that is end OR gate. So now our entity block is completed. We have started our entity block and we have ended our entity block. Next we have to write the architecture. We will use data flow modeling, so architecture, here we will write data flow. You can this is also a name. You can write the name of the architecture you want to implement, any name. So data flow of, you have to write the entity name, that is OR gate here is. So the format is architecture name of entity name is, and next we have to write begin. So it says that we are beginning our architecture. Here we will write whatever our logic is, so A or B. So A or B will be evaluated and it will be assigned to Y. Okay, so this is our architecture and we will end it. We will write end data flow, that is the architecture name. So once we have written this, we have to click on file and save, or you can use ctrl-s. Okay, now we have to click on orget.vhd, right click, compile selected. So you will see that our orget will be compiled. Next we have to click on library, we have to click on work, and we have to click on orget, and we will right click here and click on simulate. So this will be brought to a simulation window, and we will click on orget, right click, and add to wave. So this will be added to our wave window. So you can see right here that A and B are input and Y is the output. So we have to give the value of A and B. So I will right click, and you can actually give your value by force. I will give your value as clock. This is the easiest option. So I will click here clock, and in the period I will get 50. Make sure it is any value. You have to just double it in the next one. Okay, so this is my second input, and I will actually get here 100. So it is 100. If you have three values, let's say you have a variable C, you have to get it 200, that double the size. And whatever the maximum number you have put there, you have to write it here. So the maximum number was 100, here it is 100, and we will click on run. So this is our graph. I will click on plus to zoom it. So here you can see that, here you can see the values. Here you can see the values. For 1 1 it is 1, for 0 1 it is 1, for 1 0 it is 1, and only for 0 0 it is 0. This is the behavior of a OR gate, and you have already successfully implemented it using data flow modeling in Vhdl. In the next video we will implement NOT gate using Vhdl.